know?
Hello. Hello, so I am Rebecca Chang, Zhang Jingfei.
And I am Lin Ziyang. So, have you guys ever wondered how exactly can we separate different liquids in outer space? So basically here we are Team Juicy Judy and we're here to present whether on the topic of the mixing and separation of liquids with different densities in microgravity environments.
Okay, so motivation and design. On Earth, liquids with different densities naturally separate due to a gravitational pull, allowing the denser liquids to settle and form distinct layers. However, we observe that in space, density doesn't behave the same way due to the lack of gravity. So therefore, it challenges us to separate liquids in microgravity environment. This phenomenon inspired me and William Yu to explore methods in handling liquids such as fuel, biological samples, or even waste in space. So our goal is to develop a practical solution for astronauts. The design of our experiments is simple and efficient. By using the readily available materials, it can be generated by a single astronaut in a short period of time, which by creating an artificial centrifugal force, it generates an axis of rotation that becoming a artificial gravity that basically led us to separate liquids with different densities. And so this design will help efficiently separate fluids compared to other filtration methods or tips in space.
Okay, so now the abstract. The purpose of our experiment is to determine whether or not we can use centrifugal force to separate these mixtures, right? So on Earth, we're aware that density are pulled down because of gravity. The denser liquids are pulled to the bottom because of the gravity. However, this is not true in space because gravity is not present. So natural stratification will be very hard or even doesn't even exist. So this will make the separating of liquids very challenging. Okay, so our experiment will be divided into two different types. We will have two experiments running, which is our two short experiment. The first one will be rotating the bottle, the mixture, on its own, and then the second one will be holding the string and then rotating the bottle by spinning the bottle. Yes, okay.
So introducing about the experiments that we have two experiments. And then the first one requires rotating the bottle about itself, this first picture there. And then so step one, we have oil and water. And then generally having the blocks of the mixture. And then we mix them to see the result. So step two, we rotate the bottle very fast and make sure it's really fast. And then create an axis of rotation in the middle of the bottle. And that is a result. And for experiment 2 here, we could see that step 1 and step 2 are similar, just that step 2, we require a spring that attached to the top of the bottle. And then from step 3, we could see that an axis of rotation actually changed to here. So it's in the tip of the spring. And so we have the different results here.
Okay, so as we can see here, in Earth, we will see distinct layers, right? But however, in space, gravity does not exist, so we'll be seeing something like the picture over there, which is something like this one here. We'll be seeing something like this. So how exactly can we separate it? That's the way we're trying to do this. So our expected result for our first experiment was, while we are spinning the bottle on its own, the denser liquids will move outwards, while the less dense the fluid, which in this case is the oil, will move inwards. So in this case, the water will be forming pushed outside, and then the oil will be staying the inside. So for this one, experiment 2, while we are spinning the bottle, right, the denser liquid will be going out, which is in this case the water, and then while the less dense liquid, the oil, will be attaching near the top of the bottle. So why does this work? So centrifugal force is directly proportional to an object's mass. This means that the denser the liquid, the more it will experience a greater centrifugal force acting outwards from the axis of rotation. Therefore, we hypothesize that when centrifugal force is applied to a fluid mixture in space, the denser liquid, in this case the water, will move outward, while the less dense fluid, in this case the oil, will move inwards. That's why we are so proud to propose. Thank you.
Thank you.